Everybody. My name is Alan McNamee, and I was very happy to be invited to speak at the conference today. And as Usher said, I work in the CTO office of Openet. Openet is one of the Amdocs group of companies, and I've been working on our 5G strategy for the last number of years. Today I'm going to speak specifically about the 5G core and the work that we have been focusing on in the 5G core, and looking at how analytics has become a very important part in terms of the evolution of the 5G core, and how over the next number of years that analytics will become more and more important, particularly for us as we focus our attention on the 5G core. Okay, so I think in the introductory talk that we saw this morning, there was references to 5G and what 5G was bringing to the industry. From my point of view, I hear the question asked a lot. Is it just another G? And I guess the honest answer is we don't know yet. I mean, only time will tell. But from my perspective, one of the things that I see with 5G, and I've been involved with it since its initial requirements, is the ambitions that 5G has set are quite ambitious, and they're very broad. And it's in my opinion one of those ambitions is to embrace diversity across the network. And what that will mean is that actually the 5G network will sort of transition from what it has traditionally done in terms of serving humans using phones and smartphones to a much broader set of users of the network. And it's this diversity that's going to really differentiate 5G from previous generations. Now, admittedly, it will still enhance its existing capabilities. So all of the things that you would expect in terms of speed and bandwidth and latency will be improved. But from a diversity point of view, the 5G network seeks to cater for and enable bringing on a broad set of new verticals onto the network and exposing the underlying network capabilities to those verticals, which means that the 5G network will have to cater for everything from sensors to safety critical applications and everything in between. And it's with that sort of range of things that that there was a realization that no single network can meet all of these needs simultaneously. So in reality, what I think 5G will be a number of coexisting networks that are tailored to meet the specific needs of the verticals or end users for each of those. And many people will have heard of the network slicing feature of 5G, and this will be an enabler of one of the enablers for diversity. When we look at the 5G network, it's really consisting of two major components, at least from a standardization point of view. One of those is the RAN, or the radio access network, and the other is the core network. So today my talk is going to focus on the core network. The radio network is for another day, but our focus on the work that we've been doing is in the core network, and the core network, like all of the network in 5G, has undergone some significant changes and transformation as part of its evolution to the 5G network. So the new 5GC, or the 5G core, has adopted cloud-native methodologies in the way that it will deliver functionality for the core network. And what that has resulted in is the so-called softwarization of the components in the core network. So it's adopting a lot of the technologies and methodologies and paradigms that the cloud scale companies, the Googles and Amazons of the world, have used in terms of the technology that they use in their data centers, and apply those to the core network, and how the core network will work. This is important because it means that actually a lot of the things that were mentioned in the talk earlier on in terms of scalability, reliability, flexibility are all aligned with bigger industry trends in terms of what's happening in terms of global communications. If we look at the core network again, it can be divided into two main areas. One is called the control plane and one is called the user plane. And again, our focus today, and in terms of the work that we've been doing over the last number of years, is on the control plane. The control plane is the part of the network that provides the signaling control, how the communications on the 5G network are established, maintained, and released, are all driven by the functionality of the control plane. The control plane is made up of a number of what are called network functions, and each of these network functions each have their own specific role, and they interoperate and collaborate to deliver end-to-end communications in the 5G. One of the things that we have seen now as part of the 5G release is the definition of a new component called the NWDAF, or the Network Data Analytics function. And this is an area that we have been working on for the last while, and it's the platform within the 5G core network for delivering analytics and machine learning and AI techniques on top of the operation of the core network, with the goal of making the core network a more efficient, more intelligent core network. So what is this? What is the NWDAF in 5G? So the NWDAF is a single anchor point for analytics in the 5G core. In previous, actually, just pause at that. So realize that when we talk about NWDAF, its focus is on the core network. We should also pay attention that there are other areas within the network which will have their own capabilities in terms of capabilities in the management plane or capabilities in the radio plane, and how these interoperate and interact again is still evolving, and that's a conversation for another presentation. But today we will focus primarily on terms of analytics in the 5G core and what the NWDAF delivers there. So as I said, it's a single anchor point for analytics and predictions in the 5G core. In previous generations, there was analytics capabilities, but they were fragmented. An example of such would be the ORCAF capabilities in the evolved packet core of the 4G network, which looked at radio congestion. But the NWDAF is a specific network function defined within the 5G network from which specific analytics capabilities and use cases can be built upon. So if we look at the NWDAF, I mean, it's what has happened from a standardization point of view is that the standards body, and in this case 3GPP, has defined a set of standardized inputs and a standardized outputs in terms of analytics ingestion and analytics production that could be used by network functions. What has not been standardized and will not be standardized are the internal workings of the NWDAF. My colleagues in their presentations later on will discuss the work that they have done in terms of creating, let's say, valuable and innovative techniques in terms of delivering the internal workings of the NWDAF that we have built. So as I said, the NWDAF sits in the core network. It's aligned with this new architecture in the core network, which is known as the service-based architecture, which again is an architecture that's based on a new set of interoperable protocols that will be used between the different network functions, and it aligns with the same protocols and same methodologies that other network functions use in the core network. And part of that then will enable a standardized way of collecting metrics not just from core network functions, but also from other standardized, let's say, service-based components in the bigger 5G networks, such as the operations and management domain. In terms of the standardized outputs, what the standard body IE3GPP have done is defined a number of outputs that the NWDAF can produce, and those reports then can be consumed by other network functions, and the use of those network functions, the use of those analytics by the network functions depends on how it wants to, let's say, improve its own performance. In terms of the outputs, they primarily break down into two specific forms. There's statistical outputs, and then there's predictive outputs. And as I said, the network functions consume these outputs and then use that to produce actionable changes in their own performance. So if we look at 5G, the way that 5G is delivered is actually 5G is too big to be delivered in a single go. So what 3GPP is doing is it's spreading 5G capabilities over a multiple set of releases. And that same methodology applies to how analytics is evolving in the core network. So release 15, 3GPP release 15 was the first iteration of 5G. And when you look at that, the analytics capabilities that were defined were very, very simple, though it did set let's say, a blueprint in terms of how analytics would evolve within the 3GPP core network. So initially, it was very much focused on a single use case, which was related to network slice load analytics, and there was really only two consumers identified, one being the network slice selection function and one being the policy control function. What we've seen now, and the focus of our work has been around release 16. So in release 16, I think we've reached a sufficient mass of, let's say, capabilities to be able to deliver a functional analytics platform within the 5G core network. And in terms of the standardization process, the analytics has now in the core network got its own dedicated specification or set of specifications, primarily defined around the 3GPP TS 23288. And what that has seen is to the expansion in terms of the number of consumers of analytics or potential consumers of analytics in the 5G core network. And in terms of the set of outputs, depending on what way you count them, there's of the order of 10 standardized analytical outputs from the NWDAF to consumers into 5G core. There, again, as I said earlier on, the NWDAF is aligned with the service-based architecture, and in release 16, we've seen the definition of two standardized NWDAF services, network services that are exposed to consumers of analytics. In terms of where the industry is at the moment, at least most of the operators that I've spoken to are still in the early stages of evaluating the NWDAF and its capabilities. So my expectation is that most operators will probably start to deploy NWDAF solutions the start of next year through the next 18 months after that. But nonetheless, work continues to evolve the functionality of the NWDAF, and within the standards community and in 3GPP in particular, release 17 work is already underway, and that's evolving and expanding the capabilities of the NWDAF. So what we'll see is the number of standardized output reports being expanded. Again, as I said, depending on how you count them, we'll see of the order of, let's say, 15 standardized analytics outputs. The number of services that will be supported as part of this service-based architecture will be expanded. Going in the opposite direction, what we've also seen is that actually the NWDAF being decomposed into smaller microservices that can be, let's say, more aligned with the evolving distributed architecture of the 5G network as we move more and more towards edge-based networks or capabilities of the 5G network being deployed and operated at the edge. From a machine learning point of view, the NWDAF then again has seen a specialization in terms of how models are provisioned into the NWDAF instances. And again, as was mentioned in the earlier presentation, scalability is will be a key factor. So as networks grow and grow, we'll see that how analytics are distributed and transition through mobility events again needs to be catered for. And again, that's additional functionality that's been discussed as part of Release 17. If we look at and specifically, we're looking at the Release 16 use cases, or these are the Release 16 output reports from the NWDAF. They break down into a number of different output reports. Release 16, as I said, is an expansion of what we saw in Release 15. So Release 15 provided the slice load analytics, but now in Release 16, we can see that expanded to the NF load use case being one of the reports. And my colleagues will give a demonstration of NF load during their talks later on today. Similar to NF load, the network performance is another analytics output, but rather than focusing on network functions, it's focusing on RAN hardware and the capabilities and let's say operation of the likes of the GNBs in the RAN network. Again, producing outputs that can be used by consumers to optimize the performance. It also has Release 16 has seen a sort of a set of UE related outputs, and they sort of subdivide then again into abnormal and normal behavior type use cases, and then under each of those abnormal and normal use cases, then they sort of split between mobility, UE mobility, and UE communication type outputs. And again, my colleagues, as part of their demonstration, will show some capabilities or some functionality that's been enabled by the consumption of UE mobility reports coming from the NWDAF. From an abnormal behavior, I mean that that will focus on things like UEs. When we talk about UEs, that think about handsets or devices or sensors, and mobility related abnormal events can be detected, such as unexpected location or behavior in terms of ping-ponging between different cell communications. Or from a communications point of view, we can look at it in terms of large volumes of data or long-lived flows or unexpected wake-ups. And some of these can be the let's say the signatures for attacks on the network in terms of DDoS attacks and so on. One of the other use cases, which I said is probably an evolution of something that we saw in previous generations, is the use of data congestion, and it will be used to predict locations in the network where congestion is happening. And this is obviously a very important thing in mobile networks, where you see mobility across the network and the possibility for congestion events happening at different periods of the operation of the network. A couple of other use cases. The observed service experience looks at either slices or application and trying to understand the experience that's happening for that particular application or for that particular slice, and allowing let's say changes to happen in the network to either improve or let's say mitigate against service experience failures. And finally, the QoS sustainability is looking and trying to predict when a particular QoS change will happen at a particular location, and trying to understand, will a particular level of quality be able to be delivered at any particular period in time. So how can, just a couple more slides before I finish up, which are give an indication of how the NWDAF outputs can be used by different network functions in the core network. So this particular slide is focused on the policy management system in the core network, which provides the many of my colleagues call it the brain of the network. It's the system that provides the per subscriber, per session, per service control in the 5G core network. And it is one of the network functions that will most benefit from having an additional level of intelligence as input or contextual input to its policy decisions that it makes. So as I touched on earlier on, so the PCF could collect abnormal behavior information from the NWDAF and use that to, for example, to understand if there's a particular device that's in a location that it shouldn't be, and to implement and change the rules that it has around what are called service area restrictions and provide additional geofencing capabilities. Additionally, as I said, it could look at abnormal behavior from a let's say malware perspective and understand, well, actually, can we now detect or predict when a particular DDoS attack is happening and perform either throttling or gating of a traffic for a particular subscriber. Similarly, with the we've already touched on the network slice analytics. So having the ability to understand load thresholds on a particular slice and feeding that into the PCF, and the PCF then can make changes to all of the affected devices on a particular slice such that they potentially change the behavior and again reduce the load on a particular slice. We've already talked about the observed service experience, and I know this slide is about PCF, but one of the other sort of consumers potentially of observed service experience of slice analytics anyway is the CCS, the converged charging system, which by looking at the observed service experience enables it to do performance-based charging for network slicing as a service, which is a new is an enabler of a new business model for the monetization of the 5G network. So as I said almost at the start, one of the things that will be key to the sort of success of the 5G, not just being another G, is the integration of other verticals. And part of that is making sure that B2B and B2B2X type models are enabled as part of the 5G network. And the NWDAF, as we can see here, has an important part to play in that. Without going through the rest of them on this slide, I mean, they all fall into a broad, theme of actually the PCF accepting output from the NWDAF and using that then to push down specific policies to UE devices, handsets, and IoT devices to change its behavior, or to change its, let's say, its policies that are applied to us. One final one on this slide is the derivation of BDT, background data transfer policy. So in an IoT type scenario, the NWDAF can provide, for example, network performance output analytics, which can be used by the PCF to derive its policies as to when the network is least busy, such that IoT devices can do such things as upgrades or firmware updates and so on and so forth when the network is less busy. Final slide for me today is again is a further set of examples of NWDAF providing output analytics that can be consumed by different network functions in the core network. And we've already talked about the user data congestion report, and in this particular slide, we're seeing the network exposure function. Using that, the network exposure function could then use that functionality to expose to third-party applications how the network is potentially going to behave and how congestion can be taken into account by third-party applications. The AMF is the network function that is responsible for registration and mobility events in the network. So it provides the capability for let's say handsets or devices to be able to move through the network and seamlessly maintain communications as part of the mobile network. And it too can be a beneficiary of output analytics from the NWDAF, and one of those is giving it the ability to optimize or to change the algorithms that it uses in terms of paging mobile devices as they move around the network. And again, as part of the demonstrations later on, my colleagues are going to show a demonstration of how an AMF can be consume analytics and use that to adjust the paging algorithms as part of the AMF's behavior. So just to wrap up, just to say thank you very much, and I'm hoping that I've set the platform for my colleagues to dive down into a level deeper and show you how analytics will behave in terms of what we're seeing in the 5G core network, and the interesting work that they've done in terms of defining the internals of the NWDAF, and it being a platform for us to innovate and to deliver not just an NWDAF, but let's say superior capabilities in the 5G core network as a whole. So thank you very much.
Thank you, Alan.